Hello everyone. Today this class I am going to discuss with you some grading problem in electrostatics. Basically, some peculiar problems in electrostatic always there, where you need to think. You cannot solve it with ease. You have to think how it happened. Some inner view is required to solve those sums that I am going to explain. The combination of capacitors when large number of plates are in use. For a parallel plate capacitor, capacitance all of you know how to find. We give some charge to a plate, it will induce minus Q on the other plate and then plus Q, and then plus Q is removed by earthing. This is common principle, all of you know. We did this. But the problem arises, what will happen if large number of plates, suppose I have taken instead of 3 plates, instead of 2 plates I have taken 3 plates here. For this one first, let me remind you, for this, if 2 points A and B is there, we charge it in such a manner that here it obtains charge plus, then this charge minus, show this plus Q on it, only plus Q charge is there, and this is minus Q. If the distance between them is equal to D, then capacitance C equal to E0 A by D. Now the question is, what will happen if they say that there are 3 plates kept in air, they are of equal dimension. What is the capacitance between these 2 points A and B? Before we start the topic, I would like to tell you that while finding capacitance in these cases, you always need to join 2 points with 2 terminals of a battery. Between these 2 points, when you are going to find, you have to make the charge distribution also. So you first put a cell mentally or physically, you just show that a cell is there. Now if it gives plus Q charge here, minus Q here, and then this one will be plus Q, this one will be minus Q, and plus Q will be removed by earthing. Then I'll say that if this point is 1, 2, 3, then this plate is being used twice, so these 2 plates will be in series combination. What way? You just check. I'm taking between these 2 plates 1 and 2, just ordinary thing. No? See, this plate, it has one side for negative, other side for positive. It gets induced charge. This one also induced charge. Net charge of the circuit, if you give a charge Q here, this will be minus Q, this will be plus Q, more charge can be retained by it, and this one is minus Q. So net charge, see, this is not connected to any source of EMF, net charge always has to be 0. This is another case you have to remember. Whenever you take a plate which is not joined to any terminal of a battery, the net charge on it will remain 0. Okay, charge will be obtained by the plates which are connected to positive or negative terminal. This gets positive charge because connected to positive, this gets negative because it is connected to negative terminal. Remember this one. So it is combination of these 2 capacitors, and between 1, 2, and this second plate is being used again 2, 3. So this part will be plus, this part will be minus. Here this part will be plus, and this will be minus. Okay. So if this battery connection is shown, they are in series combination. Equivalent capacitance we write 1 by C equivalent equal to 1 by C plus 1 by C, that is 2 by C. Therefore C equivalent equal to C by 2. Okay. If 3 plates are given this manner, if 4 plates are given this manner, then it will be, you will see that there are 3 capacitors coming in series combination. If 4 plates are there, if it are, then equivalent capacitance for 3 plates will be, for 4 plates, sorry, 3 plates we have done this, for 4 plates, I just show you for 4 plates also. If I take this way, then between these 2 points we are supposed to find, we will go by charging again. So this will be a positive terminal, it obtains plus Q charge here, plus plus plus, minus minus minus. So this is plus Q minus Q. Again it will be inducing plus, it is not connected to any cell, so net charge on it will be 0. This will get minus, this will get plus, this will get minus, and by adding this is removed. This charge is removed. Okay. So how many capacitors here? If we name the plate size 1, 2, 3, 4, then you can see this is equivalent to say 1 and 2, then 2 is being used twice, 2 and 3, then 3 and 4. So this is the case. That is going to be, this is 1, 2, 2 is being used twice, 3 is being used twice, this is plus, 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 minus, 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 plus, plus, like this. Sorry, this is not plus, plus, this part going to be plus, plus, this gives minus, and this is by adding. So here equivalent capacitance is going to be 1 by C equivalent, 1 by C, 1 by C, 1 by C. Therefore C equivalent is what? C by 3. All of you understand. Now the question, if n plates are arranged, your answer is ready for that. For 3 we have got C by 2. For 4 we have got C by 3. For n plates, all those n minus 1 capacitors will be formed, and C equivalent going to be, here how many capacitors? 3 capacitors are formed. In the previous case 2 capacitors are formed. If you keep n plates side by side, then n minus 1 capacitors will be formed. They all will be in series combination. C by n minus 1 is the equivalent capacitance. And I remind you, charge of the circuit is going to be what? As I told you earlier also, charge of the circuit is going to be Q only. It is not Q plus Q plus Q. Okay? You can't say that charge is Q plus Q plus Q. Those are induced charges, so net charge will remain Q only. Now, what will happen? Like a question here. If they are arranged, if plates are arranged, if plates are joined alternately, then how to find equivalent capacitance? If plates are joined alternately, then let us start with 3. These two are joined by an wire, and this is different one. Our problem is to find equivalent capacitance between these 2 points A and B. So there are 3 plates. You see that these 2 are joined with the same, and this is not joined at all. To find the 3 plates are there, no, that dimension you can take A, and the distance between the plates is equal to D in each case. Then how to find the equivalent capacitance here? I remind you again by taking a battery here whose positive terminal, you take this one negative, this one positive. Positive terminal with A, negative with. You can do opposite also. Now, since this one joined to positive, it will get plus charges only. Plus, plus, plus everywhere. And this will get minus. Induced charge minus. Now, positive terminal joined to this also, this will get plus, plus, plus this way. So, this will be minus. Again, people start this kind of problems. I'd like to remind you the basic principle that if positive plate get a charge Q, negative plate has to get minus Q. If positive plate gets 2Q, negative plate has to get minus 2Q. So here it is justified. If I give a charge Q here, it is induced minus Q. if I give a charge q here, it has given minus q here. So 2q total charge in positive place, minus 2q total charge in negative place. It happens this way. Okay. So in this case, if I take this one at 1, 2 and 3, see how the connection going to be here. Between 1 and 2 there is the capacitor. All of you can see that this is plate 1, plate 2 there is a capacitor. This is plus charge, this is minus charge. Between 2 and 3, 3 and 1 there is no difference, so that they are joined to positive terminal, so I can take this one 3. On the same side 3, this also obtains positive charge, and this one, the plate 2 is being shared. So here this is like this. Okay, the point is here and the B joined to plate 2 like this. Same was connected like this. So what is equivalent capacitance here? If this one has capacitance C, this one C equivalent going to be C plus C, that is equal to 2C. Now let's see what happens if 4 plates are joined. What will happen if 4 plates are joined alternately? This way, first, second, third, fourth. These two are joined and these two are also joined. Plate 1, 2, 3, 4. Then what will be equivalent capacitance between 2 points A and B? Same way I will be doing, I join. You can do this way also. This is positive terminal, negative terminal, join together. This will obtain positive charges only. Plus, plus, plus like this. This will obtain negative charges. This also will induce minus. This will be getting plus, minus. So charge distribution done. Here there is no charge and 0. This one also 0. So with this connection, it is established that if the capacitors get plus Q charge, plus 3Q here actually, this is Q, this is Q, this is another Q, 3Q. So negative plate also getting minus Q, minus Q, minus Q. So net charge from positive plate, if it is plus 3Q, negative plate will be minus 3Q, like that. So how to find capacitance in this case? In the previous case where 3 were there, you have seen 2C. Let's see what happens there. We arrange the plates this way. Plate 1, 2. 2 is sharing with 3 also. So 3 and this part is 2 again. Now 1 and 3 is the same point. 3 sharing with 4. 4 and 2 there is no difference. So this is 4 and this is 3. Understand? This is the combination. Why? Because all these plates will get plus charges. Here also plus. Now this point will take A, this one B, they are joined by a battery. So these 3 capacitors will be in parallel combination. C equivalent in this case going to be equal to 3C. All of you know this. So for 3 plates we have seen that it is 2C. For 4 plates it is 3C. Okay. So if n plates are joined this manner, write your conclusion here. So if n plates are joined alternately, C equivalent is going to be n minus 1 into C. You will be confident if you do with 5 or 6 capacitors on your own. Do the charge distribution. Then everything will be clear. The same manner. There is no difference. Whenever you are connected to positive terminal, those plates will get positive charges. Negative terminal, those plates will get negative charges. If any plate isolated, then net charge on it will be 0 unless it is earthed. Let's see another problem. So you have got idea what series combination, parallel combination can be there. Series combination when plates are joined or just kept side by side between the first and the last. The given capacitance C by n minus 1, and here it is going to be n minus 1 into C if the plates are joined alternately. Now what will happen if a plate is inserted? Just write the question here. It's like this. You have done one thing, you have given a potential here, this be V and this one is earthed. Okay. The area of each plate equal to A and distance between two consecutive plates is equal to T. How to find the equivalent capacitance here? This one, first on the basis of previous discussion, tell me whether it is possible to make charge distribution or not. Can you make any charge distribution here? What will be the basis? Here it is given that this terminal, this point, it has some potential V, and here earthing means that has potential 0. So if a battery is there, this will provide positive charges on it. Here there will be plus charge. It will induce minus this side. This one also plus. This will induce minus here. These are bound charges, they will not go to earth. What positive charge you get due to this induction, if positive charge accumulates here, the positive charge accumulates, they will go to earth. So there is no problem in constructing a capacitor here. This be 1, this is 2, this is 3. So this time if they ask you to find, the question is, what is the charge on the capacitors? Question is right, find the charge on the plates, not capacitors, plates. See what way capacitors are arranged over there. This is plus, minus, plus, minus. So this is our V. This thing is earthed. Plus, 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 minus. This plate shared by both of them. This is 1, this is 2, this is 3. So these two capacitors are in parallel combination. If this is C, this one C, C equivalent going to be equal to 2C here. Okay. All of you understand that equivalent capacitance in this case is going to be equal to 2C. Okay. So the question was different. Question was, what will be the charge on each plate? Now if this is C and potential you have given V, then V will be shared by this capacitor as well as by this. This charge will be Q, this one will be Q. It will be same because value of C is same. So on plate 1, charge on 1 equal to Q, charge on 3 is also Q. Charge on 2 will be equal to minus 2. Okay, done. You understand? Now you consider another case where plates are arranged in such a way that initially it seems that the second plate is isolated, but you have to find the paradox. None of them are isolated. I am taking the plates this manner. plate arrangement given this way, area of this plate A, this one A, all are equal to A. Area of each plate. These are plates. Don't assume that they are straight lines. These are plates. Now your problem is to find, and distance between the plates is equal to D. This is also D. D only. Problem is to find the equivalent capacitance between A and B. How do you find it? So you'll go by the same principle again, that you'll join these two plates and in these 2 points by a battery. Okay, this is D, 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 all these are there. Now this plate will be shared by, if you name these plates now, this is plate 1, plate 2, plate 3, plate 4. Symmetry is there. If it gives a charge, if it induces minus Q here, it will induce minus Q here. So what quantity of charge it can get? And whatever quantity it assumes, similar quantity will be assumed by it also. So this we get minus, this we get minus. Now there is a problem. This plate has got 2Q. This plate has to get minus 2Q. But here, see, the problem is here there is no charge. It has become a charge. If this charge is Q, this is Q, this is minus Q, this is minus Q. Suddenly it has got minus 2Q. I told you, if it is isolated, it will assume net charge 0. Then what will happen? This side will get plus 2Q charge. And this one will have minus 2Q. Understand? So from plate A we have started first. It receives 2Q. I have to get minus 2Q on it. I go by principle of induction. It induces minus Q here. It induces minus Q here. Then as net charge has become minus 2Q, so there is a reason that charge on this side will be plus 2Q and charge on it, induced charge will be minus 2Q. Now charge distribution is fine. You can find the capacitance between two. But the thing is that here two plates, opposite plates getting QQH, they are forming a capacitor, they are also getting. How to do this? In what arrangement is it possible? This arrangement is possible when these two will be in series and when these two will be in parallel. 1, 2, 2, 3 will be parallel and they will contribute Q from this plate, this capacitor, Q from this capacitor will make 2Q here. Let's see what is happening there. So I'll take 1, 2, this is plus, 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 minus, minus, minus. Okay. Now this plate is our plate 2. This is also 2. This is 1. This is 3. Then 3 joined to 4. If 3 joined to 4, you cannot say that 1 is not joined to 4 because 1 and 3 same point. So expected that connection going to be like this. Now if this one is Q, this one minus Q, again Q minus Q, this has to be plus 2Q minus 2. Okay? So this point is our A, this one A, and this one going to be B, and the battery connection is like this. See, equivalent capacitance becoming what now? This time equivalent capacitance is going to be, these two are in parallel, so it will be 2C. This is in series, so 2C into C divided by C equivalent is going to be like this. That is 2C by 3. So in this problem, symmetry was there. We have done it. You said that it is plus Q minus Q plus Q minus Q, but suddenly, if I create some problem for you there, that the situation will change little bit. Suppose I am asking you to do the same thing with a bit modification. This point is A. These distances I want to keep same. So suddenly I have kept another point. All these distances are remaining the same. But if they differ, then also you can find. What will be equivalent capacitance between A and B? This one isolated. What will you do? Can it go by previous one, that this one Q, this one Q, so inducing? No. Because symmetry, there is lack of symmetry. Here suddenly another plate has reached, so I won't take the same kind of charge distribution there. So I'll be taking, suppose this charge is Q1, this charge is Q2. This will induce what? Minus Q1, this will induce minus Q1, this will induce. Now wait, what is happening there? Isolated plate, this plate, if I name the plates, then the isolated plate, this I am naming as 1, this one 2, 3, 4, 5. So this isolated plate has net charge 0, all of you can see. This is also isolated combination of two plates, so this also has to be 0. But we are seeing that charge is minus of Q1 minus Q2. Then I will suggest you have taken Q1 plus Q2 from again battery connection. You must do. I am doing the connection here. Between two, I will connect a battery. So if it is this is minus Q1 minus Q2, this part going to be Q1 plus Q2, then this thing will be minus of Q1 plus Q2. Okay. So plate 1, 2, 3, 4, this connection, all of you understand now. You can find the equivalent capacitance. You take this as challenge to find the value, or I do it. Okay, I'm trying for you. Plate combination that element do the same manner here. Obviously these two, this thing and this thing, these two are getting same amount of charge. You keep them in series combination. With them, this will be in parallel combination. Now name the plates here. This is 3, this is 3, 3, 2, 2 is being shared by 1 also, 3 is being shared by 4, now 1 and 4 they share with 5. So combination going to be like this. I think we don't have any problem in it. So this is our, you can say 1 or 4, this is 5. So these two in series, parallel with this and this in series. You all can do it. This will be equivalent capacitance what? C by 2. So what is equivalent here? 3C by 2 with this in series combination. So C equivalent will be 3C by 2 plus C, that is 3C by 5. Okay, so this kind of sum you try on your own, and next time I'll see what kind of problem you're facing. Thank you.